All right, MDI today is dealing with circumference again. So in terms of pi just means exact, and to the nearest tenth just means approximate. So remember that the formula for circumference is just pi times diameter. In this one they don't give us the diameter, they give us the radius. So we have to multiply that by 2 to get the diameter, so that would be 4.8 feet. So circumference would be 4.8 pi, and this is exact. And make sure we have a label, so that should be feet. And then to find your approximate, take 4.8 times 3.14, which would give us 15.072, which I'm going to round to 15.1, again, feet, and this is an approximate. On the second one, same thing, we're going to find the exact and the approximate. So for our circumference here, they've already given us the diameter, so all we have to do is just take 17 and plug it in, and then make sure we have our label. This is exact. And then for the approximate, we're going to take out the pi, and we're going to put 3.14 in its place. So 17 times 3.14 gives us 53.38, which I'm going to round to 53.4. And make sure that you have your labels. That's approximate. All right, same success criteria as day one. So we're still going to be working on calculating circumference and arc length. Again, reminder, this should already be on your orange sheet. If it's not and you want to put it there, take a couple of seconds and put it on your sheet. Remember that when we're talking about arc length, we're talking about a portion of the circumference, and so the length corresponds with the formula for circumference here. So we have just a couple of examples. I'm just going to go over B because I think we've done one like A before. So I'm going to go over B. So again, to find your arc length, you're going to do measure of arc AB over 360 times pi times the diameter. Arc length is, so this measure of arc AB here, that's this arc that's highlighted in green here. So remember, this is 60 degrees here. This is a vertical angle with this angle right here, which means that this angle is also 60 degrees. And if this is a central angle, which it has its vertex at the center, then that means that this is equal to this arc out here, which is also 60 degrees. So we can put 60 over 360 times. Now on this one, they give us just the radius here. So this radius is 7, but we need the diameter. So to find the diameter, we just multiply that by 2. So 14 pi, sorry. And then here, remember, reduce your fraction first. So 6 over 36, these are both divisible by 6. So you would have 1 over 6 times 14 pi. Turn this into one big fraction. 1 times 14 pi is just 14 pi. We have over 6. 14 over 6 will reduce down. So we can divide both of these by 2, which would give us 7 pi over 3. And the label that we're looking at is inches. And you can just leave it in exact measurement. You don't need to put 3.14 for pi if you don't want to. Okay. To learn how people really spend their time, a research firm studied the hour-by-hour activities of 3,600 people. The participants were between 18 and 90 years old. Each participant was sent a 24-hour recording sheet every March for 3 years from 2000 to 2002. The study found that people spent most of their time sleeping, working, and watching TV. Some information from the study is shown in the circle graph. Find the measure of each central angle in the circle graph. So if we look at sleep, sleep is the biggest portion up here. Okay, we can see that 31% of this circle is sleeping. So if we know that the total number of degrees in this circle is 360, all we have to do is take 360 times 31%. We can't multiply by a percent, we have to multiply by a decimal, so we just have to change that 31% into a decimal. So 31 would change into 0.31. So if we take 360 times 31%, we get 111.6 degrees. So this arc right here on sleeve accounts for 111.6 degrees of the whole circle. So for food, we would do the same thing. Food is this angle right here. So we would take 360 times 9% would not be 0.9 as a decimal, it would be 0.09, because remember you have to move your decimal point 2 places. So if we take 360 times 0.09, we get 32.4 degrees. So this food portion here is 32.4. And you can do the same thing with work, other, entertainment, and the must do. But once you get done, you should notice that all of your degrees should add up to 360. All right, on the last example that we have, I believe, we've got a major arc, a minor arc, a semicircle, and then we have to find the length of each arc. So remember, a major arc is greater than 180 degrees. A minor arc is less than 180 degrees, and a semicircle is equal to 180 degrees. So what we're doing is we're finding the length of each one of those arcs. So if we want to do a major arc, okay, so a major arc would be something like D to B to A. So this would be an example of a major arc. And it's not the only major arc that's up there, it's just one example of a major arc. So we can call this arc DBA. And what we want to do is we want to find the length of that arc. So in order to find the length of that arc, remember we're using that arc length formula, which is the measure of arc AB over 360 times circumference, pi times diameter. So in this case, in order to find the length of our arc, we know that this right here is a diameter. And so from C all the way around to A, that's 180 degrees. And we know that from D to C is 58 degrees. So the whole arc from D all the way around to A would be 180 plus 58, which would be 238 degrees over 360 degrees. I guess we don't have a diameter, do we? So maybe we can't find the length of each arc. Well, in any case, what we would do, if we knew what the diameter was, let's say that the diameter is 5, we would take, or sorry, our radius is 5, so our diameter is 10. So we would take 10 times pi. So our arc length is equal to, so we'll say this is 5 right here. 238 over 360, so if we take 238 divided by 2, we get 119 over 180, and I don't think that that can be simplified any farther, so 10 pi. And I know that since this has a 0 and this has a 0, I can cross that off, so really it's 119 pi over 18 would be the arc length for that major arc. Okay, if we were going to do a minor arc, remember the minor arc is less than 180 degrees. So if we do a minor arc, we can do one example would just be from D to A. So we could call it arc DA. We know that from C to A is 180 degrees, and so in order to find from D to A, we would just have to take 180 minus 58, which I believe would be 122 degrees. So again, we're gonna do the arc length is equal to measure of arc AB over 360 times pi d. The measure of our arc this time is 122 over 360 times, we're going to use that same diameter again, so we're going to say that it's 10. So again, simplify your fraction first, 122. I know that these are both even, so they can be divided by 2. So this would be 61 over 180 times 10 pi. And again, since this is 0 and this is 0, I can cancel those out. So I would have arc length is equal to 61 times pi would be 61 pi over 18. So the length of our orange arc up here would be 61 pi over 18. And then the last one that we need to do would be the semicircle. So a semicircle would be from C to A. And it doesn't matter which direction we go because they're both going to be the same. So semicircle, we can just call that arc CA. And so again, we're going to do arc length is equal to measure of arc AB over 360 times pi diameter. So the measure of this arc is 180 degrees over 360. And we should automatically know what that fraction reduces down to. And again, we're going to take pi times the diameter, which in this case we said is going to be 10. So 180 over 36 is the same thing as half times 10 pi. So if we take half of 10 pi, we should get arc length is equal to 10 pi over 2, which is the same thing as 5 pi. All right, these are the two formulas that we've learned over the last few days. Area, remember, uses the formula for area of a circle. Arc length, remember, uses the formula for circumference. So there's some differences, but there's also some similarities in these two, and you guys just have to know which one you're using for what.